Hi everyone, in this video I will talk about the concept of confidence interval. Confidence interval, or some people just call them CI, confidence interval. So let me start this concept by discussing or kind of going back to our previous videos that if you remember, we saw that most of the time, most our sample mean X bar are not going to equals to the population mean, right? So it's not going to equals to mu, which is the population mean. Okay? Okay. So if we want to make guess or predict or estimate population mean, instead of making or instead of using a point, a number, maybe we can do like a range. Okay. So maybe we can make a guess range instead of a point. And this range is what we call confidence interval. So this range is what we call confidence interval. Okay. Let me first give you the formula for confidence interval. Formula here. So the formula is our sample mean X bar plus minus the margin of error. Okay, so if you try to interpret this formula, is that we put or we use our sample mean to be in the middle, and then we're going to add a distance and subtract a distance to make a range. So let's say we are using the sample mean to be the middle, and then this just add and subtract a distance. Okay, so just add and subtract a distance, and therefore we can get the range. So if we expand this, we can get a range of X bar on the left hand side with minus the margin of error, and then the right hand side with X bar plus the margin of error. Okay, and this is our range here. And now let's talk about what's the distance that you want to subtract and the distance you want to add to your sample mean here. Okay, so a margin of error, the formula for margin of error equals to your critical value, the critical value multiplied by standard error. Standard error. And if you remember, standard error is just the standard deviation of your sample mean. Sigma X bar equals to sigma over square root of n. This is our population standard error, and this is our sample size. Okay, and again, this is the standard deviation of our sample mean. Cool. So we know how to calculate for the standard error. Now let's focus on getting the critical value. Critical value. Here, so critical value kind of controls, the purpose of the critical value is controls how accurate you want your confidence interval to be, right? So it controls how accurate you want your confidence interval to be. And let me connect this to the concept of the percentage confidence interval, right? Let me connect this to that. Okay, so usually we say certain percent, let's denote as Q percent confidence interval, right? So Q percent confidence interval means that your Q percent confidence, the population mean lies in the interval, right? So if you're doing a Q% confidence interval, that means Q% confidence that the population mean is inside this interval or inside this range. Okay, so we usually do 90%, right? Confidence interval, that means you're 95% confident, 90% confident, and we also do 95% confidence interval, that's 95% confident, and 99% confidence interval, that's 99% confident. Okay, so the most often Q percent you see are 9%, 9%, and 99%. Okay, so now let's connect these two concepts here. Okay, so note your critical value, the critical value you want to use when you calculate your margin of error, your critical value, is in fact based on how confident you want. So it's based on Q percent confidence. Okay, and then the way you get this is you determine the number Q, and then you're going to use your Z table to find your critical value. So let's say we're going to use our Z table, or later we might use T table, right? It depends on the scenarios that we'll discuss in the next video. Okay, so you determine your Q, you decide the Q percent you want, and then you can use Z table or T table to find your critical value. Okay. Next, let me just demonstrate to you using a distribution. Okay, so let's say we're interested in 95% confidence interval. Okay, so what it means is you want your the range to cover 90%. So if you show it on the distribution, we'll be looking at, let's say we have a normal distribution, then we'll be looking at something 90 in the middle, and then here would be 5%, right? So use 10, 100 minus 90, and then you get 10, and you're gonna divide by 2, means here you get 5%, and here you get 5%. And then the critical value that you look at is the critical value here that kind of cut off, right? Cut off 5% here, and then cut off 5% here, leave you 90% in the middle. And that's how confidence interval, the percent you're looking at, the Q, connects to your critical value. Okay, and let me give you a deeper understanding or deeper connection between the two. Okay, here. So a deeper connection, so I'll just say link between our critical value and our confidence interval. Okay, so let's say we have Q%, right? So if we have Q% and as this value gets bigger, so if this value gets large, or yeah, it gets large, then your critical value will also be large, right? So as you can see, if we expand this percentage in the middle, we're likely to move these two critical value, this one to the right and this one to the left. And if you think about them in absolute value, then you're increasing these two critical value numbers. And then your confidence interval will be larger, right? Will be large. Okay. So Q large, critical value large, and your confidence interval will be large. So let me see, yeah. So the confidence interval large means that you'll be more confident, that the true value or the population value, true value is in the interval or in the range, right? So you're more certain that the true value will be in the interval because the confidence interval, the range is bigger, right? As you increase your Q. Okay. But this is not always good to expand this range or this confidence interval because we're facing a trade-off. Okay. But the thing we have to consider is we face trade-off. Okay, what it means. So let's say if your Q percentage is very large. So if your Q is very large, then you have a very large confidence interval. All right, so you have a very large confidence interval. And the good thing is it's very likely to include the population, or let me just say the true value. Okay, yeah. The true value, or in this case, the population mean, okay, it's very likely that it will include it, but it's less meaningful. This range will give you a less meaningful range. Okay, less meaningful. Okay, so let me give you an example to tell you what it means or why is it less meaningful. Okay, so let me do an example. Let's say we're given a 99% confidence interval. So if we're given a 99% confidence interval of Cal State University Los Angeles students GPA. Okay, so we're given this range here. So the average GPA between 1.5 and 4.0, right? So we're 99% certain that the true value will in here. Yeah, so it's very likely to be true, right? So it's very likely that the true average or the population average is in here. But it's not very helpful, it's not very meaningful, it doesn't help us a lot, right? So, is it true? Yes, but it doesn't help us. The range is too wide. So, not very helpful. Okay, so as you can see, we are facing the trade-off here, right? So we're certain that the true value is in here, but the range is too wide, so it's not very helpful or very useful for us to have this range here. Okay, let me complete this by telling you the opposite, or yeah, so the opposite is also true. So if your Q is small, their confidence interval will be small, right? Be also small. And then the bad thing is less likely to include the true value. Okay, so if your range is small, then it's less likely to include the true value, but it's very meaningful. Or not very meaningful, but let's just say it's more meaningful for you to have a smaller range. Okay, more meaningful here. Okay, sounds good. So next, we'll talk about the interpretation of these confidence intervals. Okay, there are two interpretations: confidence interval interpretations. Okay, confidence interval interpretations. Let's say we have a 90% confidence interval. The first interpretation is that 90 out of 100 sample you take, right? So you take 100 samples and then you construct 100 confidence interval, and then 90 out of the 100 you take will contain the population mean. Okay, so 90 of the 100 will contain the population mean. So basically you construct 100 confidence interval, and then 90 of them will contain the population mean. Okay, that's one interpretation. Okay, and then the next interpretation is that 90% probability our confidence interval contains the population. Okay, so 90% probability that our confidence interval contains the population. Okay. That's another interpretation we have for confidence interval. Okay, so next I want to put out a note to kind of talk about the standard error part that we need to be careful for. Okay, note, right, note. Here we're going to go back to the standard error. Standard error, our definition says equals to sigma x bar equals to the population standard deviation divided by the square root of sample size. Okay, so when we use this formula, the assumption we have is we assume we know the population standard deviation. Okay, so we assume that we know the population standard deviation, but this is a really big assumption, right? Because we don't even know the population mean. How we would know the population standard deviation? So this is a huge assumption. Huge assumption. Okay, and then we'll definitely talk more about this in the next video, but here I want to just point out that in real life, this is not true, which means that hard to know the population standard deviation, but more will come later. But for now, let's say that if we know the population standard deviation, if we know sigma, then we're going to use z-table to do our calculation to help us to get critical values. And if not, we need to estimate. We need to estimate the population standard deviation with our sigma hat. And once if we have to do the estimation, then we're not going to use the z-table, but instead we're going to use the t-table. Okay, we'll talk more in our next video. But for now, you need to know this here, the population standard deviation. Whether we know it or not makes a difference on whether we have to estimate it and whether we have to use the z-table or the t-table. Okay, good. Let me quickly do an example before we end this video. Okay, so the example here, we're interested in California, people's weight. Okay, so we're interested in this, and then the population weight standard deviation is 30, and then we take a sample. We take a sample of 121 people. Okay, so we have 121 people in our sample, and then the sample mean, the sample weight mean is 153. Okay, and then the question, or what we have to do is we need to find a 99% confidence interval. The question here is to find a 99% confidence interval. Okay, so let's see what information we have. We know the population weight standard deviation, so we know this value. And then we take a sample of 121 people, so we also knew n, which means that we are able to find the standard error. We also know 153, which is our x bar, so we're ready to construct our confidence interval. So let's start by writing out the formula. Confidence interval equals to x bar plus minus margin of error, and this equals to x bar plus minus critical value times your standard error. Okay, and then we just need to plug in numbers. So we know this, and we can calculate this. And let's look for the critical value here. Okay, so since we know the population standard deviation, which means that we're going to use our z-table. Okay, so since we're finding a 99% confidence interval to look for the critical value, we're looking at 99% in the middle. So here would be 0.5% and 0.5%. And again, since we know the population standard deviation, we are going to use a z-table to do this. Okay, and then if you look for a z-table, this will be minus 2.576, and here's 2.576. Okay, and then we're going to use the positive value here, and then this equals to x bar 153 plus minus critical value is 2.576 multiply, and then the standard error, when we draw out the formula again, is sigma divided by square root of n. And that's the sigma we know is 30 divided by square root of 121. Okay, so we're ready to continue solving this, and this equals to 153 plus minus 7.025, and then the range we'll get be 145.975, and then the other side is 160.025. Okay, and this is how you construct a confidence interval, right? So you always want to start with this formula, and then what you have to be careful is whether you know the population standard deviation or not, right? If you know it, use this formula, use z-table. If not, then you have to estimate the sigma and use a t-table for the critical value, okay? So in the next video, we'll talk about when you have to estimate sigma, the population standard deviation, and you have to use your z-table, okay? Thank you for watching. I will see you in the next video.